Good morning to everybody, and welcome to Demo Days, Unleashing the Potential of Cisco HSRP and Network Redundancy. My name is Glenn. I'll be your host for the next few moments in regards to just a brief look at some redundancy in Cisco using HSRP. A little bit about me. I've been doing this for some time here at New Horizons, and prior to that as a consultant. So hopefully, if you have any questions that you have, toss them out, and hopefully we'll have answers for you when you ask. If not, we'll see if we can get them between the time we conclude our gum flapping, and then, of course, by the time we sign off. So again, welcome to everybody, and thank you for joining us this morning. To start us off, because again, we're going to take a quick look at network redundancy from a Cisco perspective with HSRP. What is it is the question that's always on the floor. So to start us off, FHRP is an umbrella. First hop redundancy protocol is where this all fits. And the idea behind it is the first hop that the clients or users or devices will need is going to be made redundant. There'll be other hops along the way, and you know the drill just like I do. You run a trace route and you can see where your packets are going. But with HSRP, it falls underneath the first hop redundancy protocol because there's some other things that can be added to it as well. But FHRP is just used to prevent network failure, specifically at the default gateway that the client is going to be using. And the way it works is going to be by configuring multiple routers with a virtual IP or a single IP, and then, of course, a virtual MAC. And what this does is presents to the clients that they have a physical device, when in all actuality, they will have a virtual device, but it will be hosted by some physical devices. The address of that virtual router, whatever the VIP device happens to be, the address is primarily going to be configured on all of the hosts, meaning you'll go and set up DHCP to hand out these addresses. And of course, DHCP will hand out the virtual IP, and then that way the clients know what to use for the default gateway. And you know as well as I do that in order to communicate on the network, you are going to need something in specific. And what you are going to need is going to be a MAC address. And of course, that MAC address will be resolved when the client needs to get to the default gateway. So the client's going to send out an ARP as always. And then, of course, they will get the virtual MAC of the virtual IP. And then, of course, once they have received that, their next move is to go in and start sending their data. Now, Cisco's development is going to be HSRP, and HSRP just falls underneath that first hop redundancy protocol umbrella because there's some other things, as I mentioned to you, that FHRP will support. It'll support multiple HSRP, and we'll talk briefly about that. It'll also support GLBP, Gateway Load Balancing Protocol, which now gives you a way to load balance. We won't really touch on that this morning because we don't have time, but the idea behind it, there's an umbrella that handles multiple things. And then, of course, the Cisco version is HSRP or GLBP. There is an industry standard version, VRRP, Virtual Routing Redundancy Protocol, that you can use in lieu of a Cisco device. So again, our focus is going to be on HSRP, and you can see it's supported on Ethernet interfaces, the sub-IFs, and of course, Ethernet link bundles. So if you choose to multi-link them together or ether channel them, you can run HSRP across those as well. So let's take a look at it and see what HSRP is going to do for us. Implementing network redundancy. So when we deal with network redundancy, you know the idea behind it. Typically, a network's going to have multiple gateways, and you've got these gateways out there for all of the hosts on the LAN. However, those individual hosts are going to have individual or single gateways configured. So in the event their gateway fails, if they don't have a secondary gateway, then they're going to be dead in the water. So how do we configure a host to use a secondary gateway is the question. And of course, here we'll take a look briefly at HSRP. So what you will see here in our scenario, we've got PC1, PC2, bottom left, bottom right. They've got their respective IP addresses, and they have the default gateway assigned. You'll see it down there of 10.1, 10.1. And of course, they will use it as the default gateway. I need my pen for a second here. And their default gateway is sitting here at router A. So what happens if router A is unavailable? Well, when they now go to look for the default gateway is not available. So they're dead in the water. They won't use this redundant topology. So we've got to fix that. Enter FHRP, first hop redundancy protocol. And the whole idea behind it is, as I mentioned to you in the very beginning, we've got an active router, and then we'll end up with a standby router. And they in turn will go through, present a virtual IP, and you'll see that virtual router in the middle of the screen. They'll present this virtual IP to the clients. And as they present this virtual IP to the clients, that's what the clients will use. Now, this virtual IP is hosted by whichever router is going to be active. And then, of course, in the event of a failure of the active router, the virtual IP is going to fail over to the surviving router. So the previously active router that has now failed is no longer available. The standby router that was now is the active router. And then it takes over. The virtual IP is hosted by every device in the group. So then this way, nothing has to change on the clients. The clients still continue to connect to the outside of wherever it is they're going through that virtual IP. The virtual IP will now just be hosted on the surviving router. Now we're going to talk more about it because I know you've got some other questions. Like what happens in the event the surviving router comes back online? Well, that's going to depend upon you. How long does it take for this failover to occur? That too will depend upon what you do. So we'll talk about that as we go through this. Shortly, you will see it. This will be the scenario that we will take a quick look at. And of course, we're just going to deal with PC1, but you'll see top of the screen, we've got router 1 and router 2. These are going to be connected via HSRP when we do make our way there. So then you'll get a chance to see how this is operating. Now, let's see if we can answer some of your questions. HSRP, you'll see it top of the screen, defines a group of routers, one active, one standby. Easy enough. How many routers can you have in an HSRP group? Well, that's really going to be dependent upon you and your budget. In most instances, we're going to put 2 in this grouping. You can go up to 4 practically, but there's no written limit by definition as to how many you can have. Again, when you start thinking about these things, how much do they cost? Do you have the budget to have these devices sit idly by? Because let me backtrack. Look at this scenario. Best case scenario, router 1 never fails. That means router 2 is not going to do anything. Router 1 will do all of the work until it fails. Then router 2 comes on board. Now, router 2 is in the HSRP group, but it's not doing anything. So here's the $64,000 question. Do you have budget to go in and start putting router 1A, router 2A in this HSRP group just to have them do nothing? So again, you don't have to answer that. It's just a question. That's why I'm telling you, you've got up to 4 is what we normally put in here, but normally we just do 2 of them. Now, you got 1 active, 1 standby. You're going to have a virtual IP that you will create. The device, HSRP, is going to create a virtual MAC to go with it. And of course, you'll talk about that MAC in just a moment. You'll see it. But once you've done this, as you know the drill with everything in Cisco, once you've configured it, you got to go in and verify. So how do I verify it? You got the show standby command, and you'll see this when we do get to it. So standby will allow you to see what is actually transpiring, meaning who's active, who's passive, or who's the standby. And of course, as I alluded to earlier, HSRP, Cisco proprietary. RC 2281 is what I think it is. And of course, VRRP is an open standard for all non-Cisco devices. So you decide how you wish to go about this. In order to do this, you are going to create the standby group, and you'll see that right here. And when you go to create this standby group, you'll have to give it a number. And that number is going to range from anywhere to 0 to 255. So you can create multiple standby groups. And again, when you create these groups, you are going to put the devices themselves, typically the layer 3 devices, into the respective group that are going to share the virtual IP. And of course, the active router is going to be the device that's doing the work. Standby router is going to be the backup. Now, just keep this tucked away in the back of your mind. HSRP comes in 2 flavors. There's going to be a version 1 and a version 2. And in and of themselves, they do the same things. They will just support some differences. The group range, meaning how many groups can you create? You've got 255 or 256 of them if you go HSRP version 1. And this is on the single device. On version 2, the range is from 0 to 4095. So you can create many more groups. HSRP is going to send hello packets, because one of the questions you may have is, how does the standby router know when the active router fails? Well, they're going to be sending hello packets. And those hello packets are going to be sent by definition every 3 seconds. So those are the hellos. So standby sends a hello, active router sends a hello. Now there is a hold time of 10 seconds. So in the event the standby doesn't receive 10 seconds worth of hellos, meaning it's typically 3 1/3, if I don't receive those hellos from my active, then I'm going to assume the active has failed. And once the active fails, now I am going to take over. Now, obviously, you can go in and change the timers if you wish. One other thing, this virtual IP has to be on the same subnet as the physical devices. So whatever subnet those physical devices are on, active and standby, the virtual IP has to be on that same subnet. The MAC address will be created zero Charlie, these are zeros. I'm trying to do this with my mouse. 0 Charlie G07 Alpha Charlie, and then in hexadecimal, this is going to be the group number right here. So 0000.0 Charlie 07.alpha Charlie, and whatever the group number is in hexadecimal, that's going to be the virtual MAC that's handed out to the clients. One final piece, let me change the color so you can actually see this. HSRP version 1. And version 2. They're going to use different multicast addresses. And because they use different multicast addresses, they are not going to communicate with each other. So when you spin it up, HSRP version 1 is the default. If you want to change it to version 2, you just use version 2, HSRP version 2. And then, of course, when you set up version 2, now changes the multicast address. It's also going to change the MAC address, because, again, the multicast is going to be 0 Charlie 9 Foxtrot 0000. All the way up to 4 F's in the last byte. So again, just be mindful of different MACs, different addresses, different amounts of groups for version 2. They are not compatible at all. You'll get a conflict if you actually try to have both of them communicate with each other. Now, high level. The group, as I mentioned to you, you will pick an IP that you're going to use. You'll see top of the screen, you got the command to configure. You'll have to go to the interface in question, and it's the standby command followed by whatever group number you want. And then, of course, IP, and then the IP address. Remember that IP address has to be on the same subnet as the interfaces are for the physical devices. Bottom of the screen, router 1, router 2. And of course, I've got an interface going north, I got an interface going south. If my clients, here's a switch, my clients are down here. This interface is the one that we're going to use for HSRP. So the virtual IP needs to be on that subnet. So whatever that happens to be. You'll see it when I get to the demo. 192.168.1.1 for router 1, and then 1.2 for router 2. And then the VIP I'm going to use is going to be 254 on the same subnet, 1.254. So again, it have to be on the same subnet. You'll see default group number be set to 0, but we go in, we change it, and we specify a group number other than 0. If you don't put a group number in there, it'll automatically assign it to group 0. But we normally go in and set up whatever groups you want, 0 to 255 or 0 to 4095 for version 2. You'll see all the routers exchange the hello messages every 3 seconds, up to 10. I am looking for them. And then in the event I don't, I'm going to take ownership of it. The roles of the routers in the group are elected, and we'll talk about what that is in just a second, based on the hellos. You'll see again, active and standby messages are sent via hello to 224.0.0.2, 1985 is the port number. With this group, HSRP group number 1, we'll go in, we'll configure it, and then of course, we will define what the virtual IP is going to be. You'll see active router is 1.1. This will be 1.2 for the active addresses, meaning the physical addresses. And then of course, notice. See this? There's the VIP. Now, when we normally do this, for whatever reason, they make this joker 1.3. And then this becomes the VIP over here. You look at the group number, you see it right there, 01 in hexadecimal. Now, how does all of this work? Well, easy enough. What's going to happen, as I mentioned to you in the very beginning, you will go in, you will configure the VIP. And in this case, we're using 192.168.1.1 with Alpha Charlie 01 as the last for the group of the MAC address. So as the client needs to get to whatever destination they need, in this case, 4.22, you know the drill, just like I do. The first thing, and let's just say that this is 192.168.1.22. Let's just make it 122 just for GP. You see it right here. Host 1 needs to talk to 4.22. So the first thing that's going to happen is ANDing. What is ANDing? ANDing is going to be what TCP/IP does each and every time to determine locality. Where am I in relation to where you want to go? And the minute I determine, as in TCP/IP, minute it determines that the destination is remote, now I need the default gateway. Destination's not on the network, so I've got to go to the default gateway. So look in the ARP cache. I know what the default gateway is 4. Sorry, in this case, it'll be 1.1. Default gateway, 1.1. I know what it is because you've configured it. You set up DHCP or you statically assigned it and you handed it out. So I know what the default gateway is. The question I have is, do I have the MAC address for it? Check the ARP cache. It's not in the ARP table. And if it's not in the ARP table, now I've got to get it. So PC1 ARPs for it. Whoever is the active router is going to respond with it. And when they respond with this, now PC1 has the MAC address it needs. And just keep in the back of your mind, router 2, not doing anything. It's just standing by. It's not doing anything. Best case scenario, does absolutely nothing. Now, having said all of that, you have to be mindful of how HSRP is going to work because you're going to want to go in and set it up. So what do I need to do when I set up HSRP? Well, first thing we're going to do is create the standby command. And of course, you've got go to your interface here, and then you will issue in the standby group command. Let me do it this way. And You'll do this. This will be first. You'll create the HSRP group with the virtual IP. So standby group, whatever number it is, and then the IP that you want to be the VIP. After you've done that, you'll do this on router 1, you'll do this on router 2. You do this on both of the devices. One's going to come up first because that'll be the one you spin up first, and then 2 will come up after that. When these devices come up after you issue this command, they are going to look for priority to determine who is the active router. You see it? Active router is going to be based off of priority. No, as in KNOW. Default priority is 100. You see the range, 0 to 255. Whoever has the higher priority will become the active router. ... Meaning the ellipsis that you see written, I'm just verbally specifying them. Whoever has the highest priority is going to become the active router, depending upon what you've done. Realistically, you're going to configure router 1. You'll bring up router 1. Once it's configured, it's going to look to see, is there anybody else running HSRP in this group? If there isn't, it's going to become the active router because nobody else is running it. Then once you got router 1 configured, you'll head over to router 2. Router 2 is going to go through the same process. When it goes through the same process, it's going to spin up, hey, is there anybody in this group running HSRP? Yes, I see router 1. Does router 1 have a higher priority than me? No, they have the same priority because the default is 100. Is router 1 the active router? Yes, we both have the same priority. He's the active router or she's the active router. So then I will kick myself down to standby simply because there already is an active router. Now, if you go in and you do this, router 2, standby group number 1, priority 110. I'm doing this on router 2, 110. The default is 100. So router 1 has a priority of 100. Router 2, you've now configured to 110. What's going to happen? Nothing. Oh, wait a minute, I thought you said the higher priority is going to take over. You haven't done something in specific in order for that to happen. Now, if you bring router 2 up first, router 2 has a higher priority. So it'll come up first. And then it will become the active. In this case, router 1 is already running and router 1 is already the active one. Now you bring them up both at the same time, higher priority will win, but you have to bring them both up at the same time. And most often you're not going to be doing that because you'll be configuring this. So you got one that you bring up at, what time is it? 8:23. And then you bring up router 2 at 8:24, 8:25. So it's going to come up after it. And when it comes up after it, it's not going to take over unless you implement preemption. See it? Standby, whatever the group number is, and then you turn on preemption. Preemption forces it to take over. But notice, you see it? It's not enabled by default. So you got to turn that on. Now, again, in and of itself, it may not be that big of a deal. It will be a big deal in just a moment. But just remember, you've got to turn on preemption because it's not enabled. And when you do turn on preemption, you always have to be cognizant that preemption will kick in as soon as that device comes online. If I'm just spinning this up, not that big of a deal. But you know, like I do, this normally tends to happen at 3 in the morning when everybody's dead asleep. And router 1 goes down. Router 2 comes up. Router 2 says to standby, takes over. Then 3:30, router 1 gets repaired. And then it comes back up. You got preemption enabled. Router 1 had a higher priority than router 2. Router 1 comes back up. And when router 1 comes back up, it takes over. However, my question to you becomes this. What is your router doing? Again, you don't have to answer that because we already know what it's doing. Depending upon where it is, this device might be doing NAT. This device could be running EIGRP, OSPF, BGP, RIP. It could be doing a whole bunch of different things. If it's running RIP, and this is worst case example, if it's running RIP, and router 1 goes down, router 2 takes over, router 1 comes back up, and preemption is enabled, router 1 is going to take the load over. But guess what hasn't happened? Routing table hasn't converged. And if the routing table hasn't converged, what is router 1 going to do? It doesn't have information in the table. So you may have to implement, just for your edification, standby preempt delay command. And the preempt delay command tells whoever is taking over, I need you to wait upwards of 300 or 3,600 seconds, which is an hour, until convergence occurs. Because again, these are routers, layer 3 devices. They're exchanging routing table information and they need to converge. And until they converge, I don't need this repaired router taken over until it has the rib and the fib. And if it has them, now you can take over. So again, depending upon what the device is, old school 6500s or 9800, like a 9813, some of those jokers take upwards of 9 minutes to come back up. And when they come up, the minute they're on the network, preemption will bring me on. But until the tables have converged, now you're going to have a problem if preemption takes over before the tables have converged. So you may want to delay those jokers so preemption does not immediately kick in. So just a consideration, just something to think about. You also have the ability to change the timers. And of course, again, you can go in and change the hello and hold timers from second values to milliseconds. And the whole idea behind the millisecond value is it's going to make it fail over or detect the failure even faster. So that's the whole idea. Drop these jokers to milliseconds and you'll see the command standby, whatever the group number is, timers is the command, and then you set the milliseconds. And of course, these milliseconds can be anywhere to 15 to 999, which is like 0.15 or 0.015 and 0.999 seconds. And then the whole time is anywhere from 0 to 3,000 milliseconds. So again, the whole idea behind modifying the timers is specifically so it can detect the failure faster to fail over. Just be mindful, the whole time should always be 3 times greater than the hello. And as I just mentioned to you, the failover delay should take routing protocol into consideration. So configure the preempt delay so that it occurs after the network has converged. You got the state transition, as I mentioned as well. And of course, these devices come up, they're going to go through these 5 states: initial, listen, speak, standby, and active. And all that means is when you configure HSRP, the devices are going to transition through this. Now, the qualifier is going to be in the event you got more than 2 devices in the group. If you have more than 2, well, not if, but always and forever, there's going to be 1 active, there will be 1 standby. So you'll have at least 2 devices specifically so the HSRP can function. 1 of them will be active, 1 will be standby. Now, in the event I have more than 2 devices, 1 is going to be active, 1 will be standby, and everybody else sits here in the listening state. And they're just going to be listening for hello messages, waiting for the active to go down. Standby moves to active, and then one of the listeners will move to standby. So again, if you have more than 2, everybody else outside of the active and standby will be in listen mode. And how this plays out is going to be like this. Every one of your devices are going to come up in the initial state. That means HSRP is not running. Once you configure it, then it's going to move to the listen state. So I've issued the standby group command and I put in the VIP. Now it's going to go to listening, and it's listening to see, are there any active or standby routers already in the group? Then once it listens to see, it's now moving to the speak state. And when it goes to the speak state, now it's going to start the election. I don't see active, passive. Let's start the election to see who can be. Router A, you'll see it over here, doesn't hear any higher priority. So after it moves into speak, I'm trying to see if I am going to become standby or active. I don't have anybody in this group with a higher priority than me. So I'll promote myself to standby. Continuing to listen, there is nobody who is active or having a higher priority than I am. So I'll promote myself to active. And this is what router A will do. Now, the qualifier, obviously, see it right there? There's a priority. Now, depending upon not whether you have preemption enabled will dictate what's going to happen. But in this case, we're just dealing with the defaults. Now, router A goes active. You now go configure router B. It too goes to listen. Once it's in listening mode, it's gonna start hearing the hellos from router A. Let's go to speak. Router A is already the active router. There is nobody else in the group with a higher priority than I, so I will promote myself to standby. And then I will sit at standby until router A goes down. HSRP, high level. I mentioned to you just a moment ago in the very beginning, in the intro, there is an alternative, meaning an additional piece, because here's the $64,000 question. Left-hand side of the screen, focus over there. Left-hand side of the screen, I've got router one, router two. They're both in the HSRP group. See router 2's priority, and I'm over here, right there, left-hand side. Priority, 110, 100. Everything's working fine. Here's the consideration. What happens, change the color, if this interface goes down? I didn't say router 2, and I didn't say the HSRP interface, because this is the HSRP interface. Remember, we turn on HSRP on the interfaces that our clients are on. That's the HSRP interface. The other side, call this one E0, this is E1. What happens if E1 goes down? You're gonna have a bad time, because HSRP is not monitoring E1. HSRP is only monitoring router 2 as a whole and E0, because that's the interface you configured it on. And if E1 goes down, now nobody can get out. The hope is you have configured routing so that in the event of that failure, this can happen, meaning the right-hand side. You see it? Packets go into router 2, but they come back out of router 2 and then get routed to router 1, and then they go out. Have you configured that? If you have not configured that, then that doesn't happen. And if that doesn't happen, now you can't get to the destination, because router 2 is not failed. So HSRP is not doing anything because router 2 nor the interface that's enabled for HSRP has done anything. So if you've configured this, now what you have is suboptimal routing. That means packets go in router 2, back out router 2 to get to router 1 to get to the outside. That's not what we want to have happen. So Cisco introduced interface tracking. And what interface tracking allows you to do is to tell, hey, HSRP, I need you to monitor an external interface in conjunction with the device and the interfaces that you're using. And when you do that, in the event of that tracked interface, in the event it goes down, I need you to decrement the priority on this device, on the active device, so that the standby can take over. See it? 110 is the priority. So that means router 2 is going to be the active router. But in the event of a tracked interface failure, now priority drops. Priority drops to 90. It drops to 90, lower than 100. Router 1 takes over. And then in that instance, now HSRP will give me the ability to do interface tracking. Give me a second here. You will have to configure it. And it's going to look like this. On router 2, you got E1, 1010 or 192.168.10.2, 10.1. That's going to be the inside interface. That's your 110 and 90. Standby group 10, set the priority. Notice the third and fourth commands. Preemption, got to turn it on. When I turn on preemption, this now allows active and standby to swap if necessary. And then the last command is to track the interface. I need to track E00. And E00 is the outside interface. And when I track it, I throw in the decrement, whatever you want to decrement it by, whatever is necessary in order for the standby router to take over. So you have to go in and configure that. And of course, you can track multiple interfaces. You don't have to track just one. You can track multiples. And you can have multiple tracking statements on the same interface if you need to. So again, that's the idea behind HSRP interface tracking. And normally we will do this simply so HSRP can monitor that outside interface. Because in the event that that interface goes down, but the device doesn't, without tracking, you're either going to have no connectivity or suboptimal routing. And then one more time, configuring interface tracking. Specify the group number, type of interface that you want to track, what number of that interface will be, and then the interface priority, how often you want to decrement it. And then this way, you now track those interfaces from the external perspective. Now we got one more piece, and then you get a chance to see it. Multi-group. This is HSRP multi-group. I mentioned to you in the very beginning what happens in best case scenario. In this case, my layer 3 switch never goes down, and everybody uses the active router. Router or switch 2 never gets used because nobody's using it. Router 1 never fails, or switch 1 never fails. So Cisco's given us the ability to statically load balance, and it's called multi-group. Now look closely at what's happening here. Start at the bottom of the screen. We got VLAN 10, VLAN 20. So we got two different VLANs for our clients. Easy enough. We got our switches, layer 3, and they are going to be primaries for their respective VLANs. So we got STP going specifically. So we've got different spanning trees. So root for VLAN 10, root for VLAN 20. With HSRP, notice what we do. VLAN 10, root for VLAN 10. You see it? I'm going to make switch 1 the primary HSRP, or the primary default gateway. And then, see it over here? Trying to draw a line under it, not through it. But you see it? We make switch 2 standby. So this way, everybody in VLAN 10 uses switch 1 to get out. In the event of a failure, switch 2 is the backup. And then the converse is true as well. VLAN 20, active for 20, primary switch for 20, and then of course, switch 1 is the standby for 20. So everybody in VLAN 20 uses switch 2. And in the event of a switch 2 failure, they can fail over to switch 1 as a backup. Now, again, that's a manual implementation because it's not going to happen automatically. You'll have to go in and configure it. Well, how am I going to configure it? Easy enough. This is switch 1 config. You'll see switch 1 right here. And what we'll do, set it up for VLAN 10. It's a primary, and then it's a backup for VLAN 20. This is spanning tree. That's STP. Then we create our VLAN interfaces, put the IP address on it, and then we create the standby group. And you see it, standby group 10. And normally these are just locally significant, but we typically make the group number indicative of the VLAN, just so we have to troubleshoot it, we'll know what's what. So standby group 10, we put the default gateway or the VIP on it. Standby group 10, set the priority for switch 1 to 110. Turn on preemption, and then you kick out. Create the interface VLAN for 20, put the IP address on it, and then create the VIP for VLAN 20. And then notice, set the priority to 90. So instead of the default of 100, set the priority to 90. This is all going to be for VLAN 20 as the backup. And then make sure we turn on preemption. This is all done on switch 1. So switch 1 top 2/3 of the screen, I've set it up primary for VLAN 10. I've set up the bottom third secondary for VLAN 20. And then we do the same thing on switch 2, just in reverse. And switch 2, we set it up as the secondary for 10, but the primary for 20. VLAN 10 interface, IP address, same VIP, lower the priority to 90, turn on preemption. So we're back up here. And then VLAN 20, which we are the primary for, set up our IP, set the VIP up, set the priority, and then preemption. And then at this point, you've now got static load balancing configured. Now, having said all of that, you've heard me flap my gums for the last few moments. What is this going to look like? Well, as I mentioned to you, we got our topology sitting here. Router 1, router 2 is where we are. And of course, PC1 and PC2 down here at the bottom of the screen. We're just going to do this on PC1 for the sake of time. PC1 has been configured with the default gateway of 254. And of course, you'll do this either with DHCP or you'll statically assign it. So when I head over to PC1, .68. We're not going to get anything because 1.254 doesn't exist. That's going to be the VIP. Now, we go to router 1. Ethernet 0.1 is where we're going to be. 192.168.1.1. Remember, PC1 is going to look at 192.168.1.254. And topology one more time. Ethernet 0.1, top left of the screen, router 1. You'll see it. Ethernet 0.1, PC1 is down on the other side of the switch. So everybody's on that same segment. And then same thing holds true for PC2. It's on the switch segment as well as on the both sides of either router 1 and 2. So with router 1, you see the IPs, 192.168.1.1, and then the other side is 2.1. So what we're going to do primarily is configure standby IP. And we'll do this on router 1. Mind. Let's do this. All right. Now, let's make sure. Wait for it. IP address, standby IP, and then kick out. Listening, speaking, and then eventually, see it? Standby, active. At this point, router 1 is HSRP. How do you know that? See it? Show standby. And then you can see there's a group, state is active. See the VIP? And then you'll see active, local, hello times, preemption is not enabled. You see the standby is unknown. You see the priority. Right down here is 100. So when I go back, see the ARP cache on router 1. There's its E01. There's the VIP. See the MAC. So again, router 1 is configured. See that? is the active router. Router 2. We do the same thing on router 2. And when we go to router 2, we got HSRP setting up as well. Eventually, listen, speak, stand by. Come on, come on, come on. See it? Now, router 2 is standby. So I go back to router 1, see it active, standby 2 active. Router 2, speak to standby. So right there, state is standby. Look at the bottom of the screen. Active router is 1-1. Top of the screen, our address is 1-2. So our address is 1-2. The active router is 1-1. The standby router is the local router. The active router is 1-1. So in and of itself, HSRP is now in play. But we want to do something else here. See what I just did? I changed the priority on router 2. And when I change the priority on router 2, it is no longer 100. It's now 110. So I've just raised the priority. But notice, see it? Active router is still 1-1. Standby is still 1-2. Reason being, preemption is not enabled. So we need to enable preemption. So let's go to router 1. And turn on preemption for router 1. Preemption for router 2. You see it? Look there. Bottom of the screen. Router 2 just changed. The minute you turned on preemption, it just went from standby to active. So state is active. Scroll back up. State is standby. Now it's active. Why? Because it has a priority or higher priority. So at this point, router 2 is the active router. So what does all this have to do with anything? Well, real quickly, let's do this. See, just changed to standby. So router 1 is now moving from active to speak and then speak to standby because preemption demoted it. So debug standby events. So just turning on HSRP debugging. So nothing's happening at the moment. At this juncture, this is, I need to go to here and here, PC1. Now let me do this. Let's go to 92.168.4.22. That's our server, top right of the screen. PC1 to the server. 422. Send 115,000 packets. Go to router 2. Shut the interface down. See it? Went from active to initialization. Interface down, change the state down. Bring it back up. Active, Interface comes back up, EIGRP comes back up. Now, this is all just done on router 2. Interface failed for whatever reason. We go to router 1, see the debug. We got a resignation receipt. Interface went down, no longer hellos. Now the active router is the local. It was 1.2, but 1.2 is no longer active. Standby router now is unknown. Now I am active. And then, of course, activate the MAC address. And as I go through this, you get a chance to see continuing to fail back over simply because the active one comes back online. But what happened with PC1? Look closely, the bottom of the screen. See it right there. We got 99%. Effectively, we lost 2 packets. Now, you can't really see them in this, but what I have done is here. This is what ended up happening. We lost 2 packets from the cutover. So again, virtual MAC moved from router 1 to router 2, or in this case, router 2 to router 1, and then back to router 2. And I just highlighted one of those drop packets. You go back and look at this, 114,998 out of 115,000. So during the cutover, we just lost 2 packets. And again, the client, nothing has to be done on the client other than giving it the default gateway. Ladies and gentlemen, that brings us to the conclusion of our brief look at HSRP, multi-group HSRP and interface tracking. Any questions? Comments? Or observations? Ladies and gentlemen, I want to thank you for your time this morning. We cover HSRP in the Encore class, the CCNP for Encore, for the CCNP for Cisco, the Encore class, the Enterprise Core. That's typically where we deal with it. You'll see it in the CCNA course. But yes, I do. Miss Cheryl, give me a second here. I think. I teach most of everything that you see on screen. I mean, obviously, you don't see course numbers, but most of everything that you see there is what I do. I spend most of my time doing Cisco and Azure, but I teach most of everything that's there. Oh, thank you, ma'am, very much. Thank you, everybody. Mark, did you have a question? I see a hand. Do not know. I'll have to check and see. Your question, Mark? The only way, and I think I'd be best served to let Brandon answer that question, because my normal answer is you'd have to be a Cisco trainer to get a copy of the slides, because that's the only way you can get those. You have to actually get permission from Cisco to have them. Outside of that, in the event you take a course, you can have the information surrounding HSRP, or you could Google it, because I mean, again, it's not private knowledge, it's just regular old HSRP. So I mean, you could look up that. Now, obviously, they won't be explained like I explained it, but you'll get more information, because again, we didn't have a lot of time. Just for your edification, everybody, my email address, bottom of the screen. Again, I want to thank everybody for your time and patience. Brandon?
Yeah, and Glenn, I'll add to that for Mark's question and for everyone else. We did record this webinar and it will be available on our website within the next couple of weeks. So please keep that in mind also, is that you'll be able to rewatch this at your convenience whenever you need to refer to it. You'll have it. It'll be both in our library that is accessible to the public and also on our YouTube. So Andrew, you actually just asked the question too. So yes, the recording will be available. I do want to thank everyone for coming today. I want to thank Glenn for his time and his efforts in preparing this. Once you leave today's webinar, you're going to get asked a 1-question survey that's asking, would you like to continue the conversation? If you do, and meaning, if you want to learn more about New Horizons, how we can support you in your professional and personal development and your learning, go ahead and say yes to that question. We'll then get you connected with the right people to be able to then understand what your needs are, what you're looking to be able to learn, and we can then get you into the right courses and right resources from there. So if you are interested in continuing the conversation, just press yes on that question. But other than that, if there's no other questions, have a wonderful rest of your day, and thank you for attending our New Horizons webinar today.
Absolutely. Mark, Andrew, Cheryl, Darla, Janine, Laura, Ted, thank you everybody for your participation this morning. Have a wonderful rest of the day, and we hope to talk to you in the future. Thank you, everybody.